All right, quiet, please. Let's get going here. Okay, quiet, please. I don't want to say it a third time. Let's go.
Jack.
Seriously, I don't want to say it a third time. Come on, let's go. All right. I did not change my calendar. I was lazy as no, I won't put names on it. I was lazy, and so everything just shifted over one day, which makes it good because then we don't have a test on a Monday. It'll be on a Tuesday. Okay. All right. So here is your homework. Just copy down real quick. Let me take care of that.
It don't work. Should I have it in the beginning?
No, I gotta show you some new stuff.
Keep playing Fortnite. I'm gonna get. I just wasn't like feeling it today. Oh, cool. If you couldn't tell.
No, it was like so amazing.
You got the spin. You get the spin.
Oh, ate it. Oh, I got the spin.
From there? Yeah. There's a rating 10 minutes. There's a rating 10 minutes. So one star, so you guys can easily beat it.
Why do you guys have to go get or out?
Let me see what the one star can be.
We will.
All right. Here we go. Big picture. You guys were not very impressed when I said that what we're about quarter. You guys were not very impressed when I said what we're about to do is challenging. You're like, the only reason you found it not challenging because you paid attention. Yeah. If I get that level of attention every day, I mean, the rest of algebra will be like that. And by the way, that's into next year geometry, algebra 2, depending upon how much more math you take. It's always like that. If you put some effort into it, it turns out fine. I'm not saying, wow, I'll guarantee to make an A. I'm just saying that there's a it's a causation, not a correlation. There's a causation between paying attention and getting good grades, right? I mean, the challenge is, well, you got to stay on your toes for what, 8 hours? That's really a challenging thing. That's why a lot of kids can't wait to get to college because then it's not 8 hours a day. You got to pay attention. But high school is tough. I mean, 8 hours a day, you sit there and you got to be in the receive and the on mode. So kudos for those of you that can do that. I know I was not as well as some of you guys can do that. Here's what we did yesterday, right? Or the day before yesterday, is what we did was solving a system of equations by a second technique. On Monday when we review this, when we literally review this, I'll throw the graphing in there as well too, so that we don't lose that skill as well too. But we have two techniques now to solve a system of equations. Two equations where the two lines intersect. One graphing, and now one substitution. We only use substitution if we can't graph it, either because we literally can't find it at a lattice point. Unfortunately, you won't know that until you graph it. Or two, I mean, the numbers are just really bad. The y-intercept is, so far away from the other one that you couldn't physically graph it very easily, or you don't have a graphing calculator in your hand. Lastly, the real reason on the test, I'm going to, by the way, we get to test day, I will, other than using your graphing calculator, I will give you the option to solve it by graphing, substitution, or elimination. I'm going to show you these three techniques, and then you get to pick which one you think is best. Now, I'm not going to let you sit there be flapping and like, well, I don't know which one I should choose. It's really clear what you should choose. Substitution is when one of the equations is already solved for a variable. If that's not the case, use elimination. If I give you a graph, obviously I'm trying to tell you, hint, 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 you can solve it using graphing. All right, so this is as ugly as it should get. A couple of the ones you did last night for homework are uglier than this. Those are the ones you should use elimination for. If no equation has anything solved for it, use elimination. I gave you a couple last night because they're trying to be mean to you. But check it out. I got two equations here. One is in standard form. That means you got y and x. Integers attached to everything. And the other one, it's standard form, but I got a y right here. I still would use elimination for this one, by the way. The classic one is when one of them is y equals mx plus b and the other one is in standard form. That is substitution any day of the week. And it's the quickest way to do it. So as ugly as it gets, at least right now, when they force you to use substitution, then you make a wise choice. You go to the one equation that has one of the letters almost all by itself, and you solve for this. I add 2x to both sides, and now I have one of the form y equals mx plus b. Like I said, this right here is when you are given the choice of when you would use substitution, when it looks like this and this. It looks like this from the very start. Once you learn elimination, you're going to use elimination to solve that one. All right. We do a little bit of algebra, and we get one of the equations solved for itself, and now we do our substitution. The steps are written right here. We got one of the variables by itself. That's step one. Step number two is, I only wrote this a second time just so they would be level with each other, right? You didn't have to write it a second time. We take what y is equal. It says wherever you see the letter y, you can write 2x minus 3. So we go to the second equation. We write it from left to right. There's a 3, but when we get to y, it says I can write 2x minus 3 with parentheses. So that's my substitution. I'm substituting into the second equation the value for y of 2x minus 3. You got to have parentheses. The parentheses mean there's a distributive property involved. Occasionally, you might forget to write the second thing. Be careful with that. I distribute the 3 to the inside. That's going to give me 6x. That's going to give me minus 9. Notice I'm lazy. I'm not writing my 2 arrows. Once you get past Algebra 1, I mean, you've done the distributive property for 3 years in a row. We assume that you can do it without putting arrows. If you still need to put arrows, good on you, right? 1 arrow at a time, 6x. Second arrow, negative 9. Combine like terms, I got a 6x and a 4x, that gives me 10x. Add 9 to both sides, 23. Ugly, I get an ugly, ugly, ugly answer. A lot of times you'll get a fractional answer. This one, because we're dividing by 10, that one's easy to do. If that had been a 7x equals 23, then it would be 23 over 7. And that's what you'd have to substitute in step 4 for your last time. So substitution requires 2 substitutions. You get to pick which one you think you want to use, which one looks easy. By the way, you will get the same answer no matter which one you choose. Choose wisely. Clearly, that one is easier. And where am I getting that's easier? If I throw this x into this one right here, the 3y plus 4x equals 14, I got to multiply 2.3 times 4, subtract it from both sides, and then divide by 3. I can see there's a whole lot of work involved. Where this one, okay, all I got to do is multiply by 2 and then subtract 3. There's no division involved. That's why this one, the one on the left there, is slightly easier. Saves me 1 step. That gives me 4.6 and 4.6 was the one we did yesterday that Sierra did. 4.6 minus 3 is 1.6. Okay. If there's I made it to the the 1 yard line and I screwed it up, is because a lot of times when you're writing it like the way I did it, depending upon which you solve for first, x or y, sometimes these can be backwards from each other. Notice it says y and then x. That's a silly mistake if you write it like that instead of x comma y. Remember, big picture, what are we finding? Where do the 2 lines intersect? They intersect at 2.3 comma 1.6. We did all of this without graphing. By the way, if we had graphed both equations, well, we would have still had to put them both in the form of y equals mx plus b. And then we would have found that they would have intersected at a non-lattice point. That's why it's literally 2.3, 1.6. If you had a graphing calculator from the very start, you still couldn't have used this with a graphing calculator. You would have to make both of these say y equals mx plus b. Now with online, with a Desmos, you can type it in exactly the way it appears right there. I would assume that within, I don't know, 5 or 10 years, graphing calculator will be able to do the same thing. But for right now, the graphing calculator that you have all needs, if you've used the calculator, has to say y equals. What's up? Say again? I put one on your desk. I literally did. I put one on your desk. Oh, he took it, which is why he's not saying anything. I was like, I distinctly remember that you walked in and I remember putting it on your desk. All right, this is as ugly as it gets, right? I will just say, me, math teacher, we kind of put math teacher problems on tests and quizzes. There's no quiz for this chapter. When I give you a test and I say solve by substitution, I give you one where the answers are nice and friendly, like 1, 2. 1, it makes my job easier for checking your work, and then two, it makes it easier for you as well too. So I generally give you math-friendly questions. All right. So strangely enough, especially from this class, I usually get a couple very vocal students. I know boys in the back, you're not paying attention. I usually get the question of, this is stupid. What is this even good for? When would I ever use this in real life? Believe it or not, if you use math in your job, system of equations is something everyone uses. If you use math in your job, okay? Here are a couple of examples of how it would be used in real life. One of the classic ones I always say is, I don't know, when cell phones came out and everyone got cell phones, every single math book in the world had a system of equations involving cell phones. Like it was asking people to compare the prices of two different manufacturers and plans and whatnot. And that's okay, true. But I'll just say businesses that use math, and there are no businesses that don't use math, businesses that use math to look at things and analyze things, they use system of equations all the time. The most classic one is what's called the profit and manufacturing cost one. So for instance, they will build something. Let's say they make, I don't know, $5 off of everything they make, right? So they have a curve that says if you buy one, they make $5. If you buy two, $10, $3. And so they have a curve, they call it a curve, it's a line that looks like this. Well, I have another thing that's called the manufacturing cost. Well, how much does it cost to make something, right? The cost, right, to make one thing includes all the people that show up to work that day, all the electricity, the building. So the cost starts off really high to make one thing. You make one shoe, it costs thousands and hundreds of thousands of dollars to make one shoe. You got to buy the machine to make the shoe. You got to hire the people to make the shoe. Because I guess in the big picture, you don't make one shoe, you make 1,000 shoes. But the cost to make one shoe is incredibly high. So that cost remains stable until these two lines intersect. And where those two lines intersect, if you go into business, this is where you start making money. Where the cost goes from, whether you make one shoe or 1,000 shoe, it only goes up a little bit. But your profits continue to go up if you sell more and more and more. And where these two lines cross over is where you actually start making money, right? You're not spending $100,000 and you only sell 2 shoes. You spend $100,000 and you sell 2,000 shoes. Hey, now you're actually making some money type thing. This is the classic one in real life, like non-math book life, where a person of ourselves, right, would use something like this. Like, when am I gonna, it's called the break-even point. When am I gonna break even? How many shoes do I gotta sell in order for me to make some profit? Even though you might be making $5 per shoe, it didn't cost you $5 to start making the shoes. It cost you $100,000 to buy the machines and the people to make them. So that's probably what typically say, when would I ever use this? Well, businesses use this, they have to. You can't be in business if you don't know where your two lines intersect, right? By the way, this is a system of equations. All right, so here is our math books example. And I'm not sure why that's in the way, but it says a snack bar sells 2 sizes of snack packs. You got a large one and a small one. The large one is $5 and the small one costs $3. Snack pack, right? In one day, the snack bar at the school or whatever sold 60 of these suckers. Doesn't say how many of each, but it says 60 in total. That includes smalls and large. It made $220. Well, it's asking, well, how much does each one? How many of each one did it sell? I don't know. Well, shouldn't the people selling it keep track of this? This is your standard math book question for system of equations. I only throw it up there, wanted to point out the obvious fallacy of the question. The person selling it would know this, but this particular problem is the one that you encounter the most. They just changed the scenario. Instead of selling snack packs, it's, I don't know, you go to a movie theater and there's adult price and there's a kid price. This setup is used all the time, so that's why I'm okay with showing you this one example. All right, Porter, what 2 things am I selling here? A large and a small. So we need variables. What's the obvious choice for large and small? And an L and an S. Okay. So I'm going to have two things. One for how much do things cost, and one for how many did I sell. These are going to give us our two equations that we can finally graph or use elimination substitution to find out the answer to this. So my first one, blue, we'll just talk about money. Well, there's three things here that talk about money. I like my eyeball is just literally going to where the dollar sign is. Where's the dollar sign right here? What's that say? $5 for the what? $5 for large. And how much did I sell? Not how many, but how much did I make? I made $220. So I can set up a pretty easy equation. How much for a large? And he said, what were we going to use for large? L. So 5L. We're going to add that to how many smalls, right? Well, 3, and what we're going to use for a variable there? For small? So 5L plus 3S equals 220. There's my first equation. Okay. The large are $5, the smalls are 3. My total that I sold was $220. So large plus small equals 220. But further, I know large is $5, so 5L plus 3. There's my first equation. Oh, by the way, you're not graphing this without a graphing calculator, right? The numbers are too big. Okay. Snacks sold. It doesn't tell me how many snacks I sold per large or small. It just tells me the total. How many did we sell in total? So that means if L is large and S is small, L plus S. This basic setup, large plus small equals 60. This basic setup is repeated over and over and over again when you do these word problems. Now I have two equations. Now we either grab a graphing calculator, we graph it. Oh, y-intercept is going to be 220, too large. And this one's even 60, it's large as well too. So we could take that and we could quickly, instead of solving it by graphing, solving it by substitution. Okay, so these are my two equations that I would now have to actually solve for. So there they are again. I flip-flopped them. Why? Because that's the one I'm going to solve for. Why? Because that's the easiest one. I could solve for L over here. I could solve for S. I get a really ugly fraction. I just move an L or an S and I'm done with this one. What do you want to move, Roland? L or the S?
The L.
Okay, so what are we going to do to both sides?
Subtract L.
Subtract L from both sides. I think I chose S. Sorry, but it'd be the same thing, right? So if I subtract S from both sides, I get that. And now I have one equation, right? Solve for one variable. I can take that and toss that into my second equation. So that's my substitution. Once again, most people probably wouldn't rewrite it a second time. They would just simply write it right here. I just want to keep it nice and level. So I'm going to take this right here, minus S plus 60, and whenever I see an L, I'm going to write parentheses, minus S plus 60. Who's lost? Distributive property. Can anybody do that in their head? Negative 5S. Positive or negative? No.
Oh, negative 5S.
Negative 5S. Keep talking. 5 times 60 is what? Thank you. Negative 5S and 3S. Positive, negative, negative 2S. Now what to both sides? Subtract the 300 from both sides. Anybody do that in their head? Subtract 300? How about just negative 80? Right? Therefore, S is equal to? S is equal to 40. What did we let S stand for? Small. So how many smalls did we sell? 40. So how many larges did we sell? If we sell 40 small, we sold 20 because we sold a total of, I'm going to go back to the original screen, because we sold a total of 60, and you just found out using solving a system of equations, you found out that you sold 40 smalls. Therefore, you have to have sold 20. I mean, you need to use substitution because I can do that math quickly in my head. But if you throw it into either one of the equations, you still get 20. All right. There's an example from our book of a word problem involving a system of equations. I like mine a little bit better than this one right here. On a normal day, not a Friday, we would actually do the next one. Look at the next one just real quick. Notice it's the same problem. You get two things. What are the two things? We got video games and we got, okay, we got rental, we got buying, right? So you got two things. You're going to be given a quantity of something, total, and you're going to be given an amount of value for everything put together. It's the same problem, just a different scenario. Okay. If you're curious about that, we could solve that, but we're going to move on. All right, everybody look at the board. Remember, when we solve a system of equations, three things happen. The first one is what typically happens. The lines intersect. When the lines intersect, where they intersect is the answer. If both lines are exactly the same, when we never solve this at all when we graph. Why? Because when I gave you the two equations, it would literally say y equals 2x plus 1, y equals 2x plus 1. There's no hiding it. Now, because both equations will look different than each other, you possibly can get this and not realize that it's the same line. Aiden, you with me? Hey, that's not what it looks like when you're with me. Okay. The other thing that can happen, and we did see this with graphing, is when we graph, we get two parallel lines. These three things will happen during substitution. Well, you just spent a whole homework, and you'll get another one tonight, of the first one. Okay, you solve by substitution, find where they intersect, x, y. These two will now pop up. So we're going to see what that looks like for substitution when you get infinite solutions and no solutions. Remember, infinitely many solution means the two lines are exactly the same. If they're parallel lines, it means no, they don't intersect. So what is that going to look like when we solve it? Brandon, we've already seen the first one, so I'll give you one for infinite and one for no solution. So here we go. Watch the board. Do these look alike? They look different, right? So most of the time you won't be able to identify unless you're really on the ball. Oh, these are exactly the same. By the way, these are exactly the same.
You're so cool, Mr. Chartier.
Why are these exactly the same?
I don't know. Because if you do that,
You just multiply this by 2, you get 2y, 4x. Wait, there's a negative 4. Yeah, but I moved the 4x to the other side. You see what I mean by you won't be able to tell just by looking at them? These are actually the same equations. They just visibly look different. Most of the time when you're going on a test or quiz, you won't even notice that they're exactly the same until you do some math to it. So here we go. Hey, this one is already solved for y, so we can do a quick substitution. Wherever I see a y, I write 2x plus 3. I see a y, so I write a 2x plus 3. Distributive property? 4x minus 4x. So I'm left with 6 equals 6. This is what it will look like when you get infinite solutions. Okay? When it's not infinite solutions, it won't be a 4x and a 4x. It'll be a 4x and a 5x or something, right? You'll get an x equals something. So here's what happens when both of the variables dropped away and you're left with a true statement. If you're left with a true statement, it's infinite solutions. Who's not paying attention? Okay? No solutions. Remember, no solutions is parallel lines. Can you tell that you have parallel lines right now?
Yeah.
How?
No, you cannot. If you divide the 9 by 3.
Well, that's what I'm saying. So can you tell, as it visibly appears right now, that you have parallel lines?
No, you do not.
And you won't. And the issue is that you're going to you'll do like 6 of the ones where you do get an answer, and then this one will sneak up on you, and you won't be thinking that far ahead. Can you do it if you're really on the ball? The answer is yes, but most likely, sometimes even I don't even get it. Like, oh, you're right, same slopes. So what typically happens is you get involved in the solve by substitution, which is perfectly fine. You're just doing a little bit extra work. So it says if you see the letter y, you write negative 3x plus 1. So I see a y, I write negative 3x plus 1. Distributive property?
Negative 9x.
And look, we got a 9x and a minus 9x. Now what happens?
3. Choose the math.
True or false?
No, not true.
Okay, so when that happens and you have no solutions, this is what will visibly occur. Meaning like you'll do the math, you'll do the substitution, you'll be going along, trucking along and doing the math. And then all of a sudden you're like, oh wait, 9x minus 9x is 0. So I'm left with 3 equals 6. Some students, and it's usually the students aren't paying attention right now, they're very uncomfortable with 9x minus 9x. You know what they put?
-18.
When they have a 9x minus 9x, what most of them will write? They'll say the answer is x, because they're very uncomfortable with writing a 0. 9x minus 9, well, 9 minus 9 is 0, but x minus x is also 0. 9x minus 9x, well, technically is 0 times x, which is 0. In other words, 9x minus 9x is nothing. Same over here, 4x minus 4x is nothing, it goes away. Be comfortable and ready to be able to write nothing if you see 9x minus 9x or whatever it is. I still will see, and one of you out there will do it. You'll say 9x minus 9x, and the answer is
18.
well, nobody writes that, but they will. Somebody will write x.
3.
They're just really uncomfortable with writing. It goes away. All right. With great amount of trepidation, I ask you, are we okay with this? Tonight for homework, this will happen. Both of these. You'll get an infinite solution. You'll get a no solution. Most of the ones tonight for homework are, well, you do the math, the intersection point is 1, 2 or something like that. But at least one, if not 2 of the answers are either infinite solutions or no solutions. Aiden, in your own words, tell me, how do you tell whether it's 1 solution, no solutions, or infinite solutions?
You look at it.
Tell me what you're looking at.
You're looking at the how the work is going.
Okay, so tell me how you visually tell whether it's no solutions.
Oh, no, that's what we just did.
Tell me what we just did.
Just did is the math. The word.
So what is it visibly going to look like if the answer is no solutions?
The answer is going to be like the same thing. I don't know. I was messing around with my calculator. I don't know.
Your calculator won't tell you this, by the way.
I know.
No.
That's why I was messing around.
What is it going to look like in the very last step if it's no solutions?
It's going to look different than what it is before.
So give me an example.
Like, I don't know.
That's why I know you don't know. And that's why I just want you to understand this basic concept. You're going to do exactly the same thing as we did on Wednesday. Substitution. What's going to happen for no solutions is at the very end, instead of it saying x is equal to 1, it's going to say 4 is equal to 6 or something else that's weird.
You said 6 is equal to 6. It's not.
No, that's not true for no solutions.
No, so that's
For
the-
no solutions, you're going to get the variables go away and you're left with an equation that doesn't make sense. Guess what happens if you do the math wrong? You can still get to this, so you got to be careful, obviously. All right, Aiden, what does it look like visibly when you have infinite solutions?
Same number.
It will be the same. Now you're on. So you'll get, I mean, I'm picking 6, it could be any number, including 0. You get 0 equals 0. So if you get 0 equals 0 or 4 equals 4, this is infinite solutions. Okay? Who's lost on that?
Why did you do a square?
That's the symbol for infinity.
That's the circle with the line in it.
That's the symbol for infinity.
Why is that like this?
Because I didn't get to make it up.
Undefined. Oh, yeah.
The symbol for undefined or no solution is like that, right? And this is infinite. And you want to know why they chose that one?
Because there's no
What does infinity mean?
There is no
It goes on forever.
Goes on forever and never stops. So why did they choose that symbol? They could have chose that one, but that one's already taken up with 0. So if you trace it, you never have to lift your pen off. It just continues on forever. All right.
Did you know there's something called a parallel?
Okay, let's do one of these. Here we go. Box number 3. Let's do one of these. Grab your pencils. Let's do one of these. Box 3. Put your calculators down. Grab your pencil. Here we go. Box number 3. Hey, It says y equals 3x minus 11. So anywhere we see a y, we can write,
Y equals blah, blah, blah.
I see a y, so write 3x minus 11 in parentheses.
The 3x can cancel each other.
Hey, what happens here? So what do you get as an answer?
0x.
You get negative 11 equals negative 13, therefore, that didn't take much time to do,
Oh, it didn't.
right? The problem is if you weren't paying, which why I made a point of, let's pay attention now. You weren't paying attention, then a lot of kids are hesitant to write 3x minus 3x goes away. They want to write x minus 11, then they get an answer. Clearly. All right, here we go. Box 4. First step, box number 4. Tristan, which one are we going to pick? Which one's easier to mess with? First one or left or right? Okay. You said both answers. Which one is easiest to mess with to get a letter by itself? The right one. So notice y is by itself, make smart choices. You can do it to this side as well. This one isn't that bad actually, but sometimes it can be bad. Let's solve for y on the second one. What are we going to do to both sides? Subtract what? Subtract 2x from both sides. We get that. We okay? This is what we're going to toss in over here. We're going to toss in this over there for the y. Ooh, big numbers. What is that going to give us? Negative 12x plus 36 plus 12x equals 36. 12x minus 12x. So we get 36 equals 36, therefore. I want you to look at the yellow. From the very start, when you look at it, it's hard to tell that this one was an infinite solution. Now, maybe if you're really on the ball and you're paying attention, hey, look, everything's been multiplied by 6. Okay, but I usually don't notice it myself either. I just go through the procedure and see what happens. If you're really on the ball, I mean, they can mix it up so they can really trick you too. So just be careful. I mean, the best bet is just simply do the math and come up with your answer. All right, Lily, are you scared right now? You should be, because we haven't done much of the other ones. The day that you missed, we did at least 6 of these where there was a solution. All right, so let's do one, Lily, where there is a solution. This one's going to have a solution. Okay. This is box number 5. This one has a solution. All right, Lily, the procedure is step number 1. I'm going to give you 2 equations. You take one equation and you either solve for x or y. Or if you're lucky, one's already been done for you. So I'm going to solve for y. Look, it's already solve for y just means y by itself. It says when you see the y, we can write 5x. So we come to this one. When we see a y, instead of writing y, we write 5x. So x is x. Hey, there's a y. So plus 5x. 5x and x is 6x. We solve for x. That's your first substitution, is when you do this substitution. You solve for one letter, and on the second one, you substitute in for that. Whenever you see this letter, you write 5x. Okay? The second substitution is, this is half of the answer. We take this and we go back to either one. Sophia, which is the easiest one to mess with, the left one or the right one? Left one. Okay? And we now let x be the value 2. So we let x be the value 2 and we get a y value of 10. Therefore, where do the 2 lines intersect? They intersect at 2, 10. Okay, who's lost? There's the 3 things that can happen. By the way, this is the most common. I mean, most of the times the lines will intersect. Only rarely are they parallel or are they literally the same line. Tonight for homework on the worksheet, have you already done it? Did any of them, no solutions, infinite solutions? There are 3 answers that are no solutions infinite. I'm literally done, and there's 5 minutes left of class. All right, boys in the back.
That sounds like a boy band.
A bad one too, right? We went from what we did on Wednesday to today. We did basically 2 things. One, I showed you just 2 examples of a word problem. We only really did one. The other thing that we did was we introduced the infinite and no solutions. So all of you, with exception of Lily, who wasn't here, all claimed that it was easy to do this. Hey, the way you get good at this is you actually do it. As always, when I hand out on the second day, when I hand out the worksheets, the answers are already here. Don't be lazy and do the work, right? Trust me when I say, we just solved that one really quick. Now, they're not all that easy like that one, but most of them are. Right? When you get good at this, you can do a substitution one in under a minute and a half, like 2 minutes tops, right? But if you don't practice this, this is one of those skills that it doesn't become any easier without practice. It only becomes confusing. You already stole one, yes? All right, I still need your homework though. No, lower that piece. If you can tell me the name of the rope that raises the sails, I will give you free homework for 3 homework assignments.
What is it, the rope?
What is the name of the rope that raises the sails? It's not called the sail rope. You get one?
We take like
Anybody know?
The hoist.
the hoist.
The mast.
The mast is what holds up the sails.
Is it the rig?
The rigging is what holds up the mast.
The rope.
I know this and this.
It's
The
called
hoist,
the
the
rope.
hoist.
Sailors give 2 names. I don't know why. They're weird. Sailors give 2 names for the ropes on a boat.
Wait.
The ropes that hold up the.
Don't say it. Land knows it.
Wait,
I studied.
There are 2 types of ropes. One that holds up the rope, the mast,
Did it start with an H?
and one that holds up
Is there the H?
the sails themselves.
Halyard.
It does start with an H.
Halyard.
Halyard.
A who?
Like that.
Halyard.
Spell it.
HALYARD.
Where did you get that word from?
I learned this like a long time ago.
Halyard.
You are correct.
Yo, I just have 3 homework. Yo, let's go.
Me too.
Yeah, me too. 'Cause I know
Me
it's
too.
That was one person that came up with that.
Let's go. I got it.
All right.
No, I told you.
I get 3 homework passes.
Yes,
Can I
but
pass the one that?
you cannot use them concurrently, like one after the other.
Can I borrow one?
Can I use the one that?
Sorry.
you just turned in?
I got distracted with my random trivia there. All right, I need your homework. I've got it from a couple people, but not everyone.
Can I use my homework pass on this homework? And then not use it for next?
Let's not do that one for this one.
He didn't do it.
Homework. Chris, you got your homework? Or are we gonna have another email back and forth session to find out that it was you that was making this stuff up like me? You know what your brother did? Yeah. So your brother sends me this email yesterday saying, hey, you gave me a 0. I did my homework. Why did you give me a 0? So he marches in the room, like busts open the door, and he changed my grade yet? And I said, Chris, I didn't do anything because it was snow day. I played video games. And then I said, well, what if the first thing you do, Chris, before you blame me is open up your notebook. So guess what he does? He gets his notebook and he opens it up, and guess what literally is right there? His homework.
You did a good job, Chris.
I was surprised.
All right, Lily, I am worried because this is a little complicated. Oh, okay. How about the ones where none of the equations have anything solved? The first one I did and the weird thing about that too is that in this third technique called elimination, that's how we're gonna solve that.
I love you.
Why is everybody's stuff still here?
Because we're in here today.
Oh, it's Friday, bro. All right, anyone online? Online learners, anyone live? No one is live. You guys have a good weekend. A lot of times this is the more challenging stuff, so you might have questions. Don't hesitate to send me a chat or email. But if not, have a great weekend and I'll see you on Monday.
Yeah, my fingers.